So for problem 6a, we're asked to find the radius and the interval of convergence. So let's do the ratio test. That's going to require us to find this limit. N plus 1th term on the bottom, or n plus 1th term first, multiplied by the reciprocal of the nth term. So it should look something like this. Absolute value again. Okay, so here, as before, n plus 1 power on the x plus 1, n power on the x plus 1 there. That's going to basically just cancel that and all of this. So all we're left with there is x plus 1. Let's go ahead and bring that out. So we'll get x plus 1. Absolute value bars have to stay around it. Let's rewrite this as, well, the denominator anyway. Copy the numerator. We'll rewrite the denominator as 3 times 3 to the n. And leave that one alone. Okay, so these will cancel. So that 3 down in the denominator, we can pull that out as well. So we'll have x plus 1 over 3. And then what's left? N squared over n plus 1 squared. If we can see that, kind of running out of room there. But anyway, that limit right there, both have second powers. If you expand that, you get second power of n in the denominator. And the ratio there is, or the ratio of the leading coefficients is just 1 over 1. So that leaves us with just this term there as our limit. So we've got x plus 1 absolute value over 3. And remember, for convergence to happen, what we want to see is that we want that to be less than 1 for convergence. So we need x plus 1 over 3 absolute value to be less than 1. Not equal to, just less than. Get rid of that. Okay, so to solve this, I can multiply both sides by 3. So I'm going to get absolute value x plus 1 less than 3. That tells us that this thing here is the radius of convergence. And we're also asked to find the interval, so we're going to have to go a little bit farther on this. We'll go ahead and rewrite this as a compound inequality. We'll say it's minus 3 less than x plus 1 less than 3. If I subtract 1 from everything on that inequality, then I'm going to get minus 4 less than x less than 2. So this is the interval of convergence from minus 4 to 2. But remember that the ratio test does not tell us what happens at the endpoints of this interval. So the next step is we're going to have to figure out what happens at those two endpoints. So let's see what happens at the left endpoint at x equals minus 4. To do that, we'll plug in minus 4 here. So minus 4 plus 1 is minus 3. So we'll get minus 3 to the n there. So this is what the series looks like for n equals negative 4, for x equals negative 4. So we'll get minus 3 to the n over 3 to the n squared. That numerator, you can rewrite it as minus 1 to the n times 3 to the n. We got 3 to the n there, n squared. Okay, so now notice that these 3 to the n's cancel each other out, and all we're left with is n equal 1 of this. Okay, now remember that often you can actually test both endpoints at the same time. This is one of those cases. Notice what would happen if you were to put x equals positive 2 into this thing. Then I'd have 2 plus 1 here to the n. That's 3 to the n, and then those cancel, and all I'm left with is 1 over n squared. Well, 1 over n squared is simply the absolute value of this thing. So we can actually use that absolute value theorem and say, well, if I do take the absolute value of this thing, and it converges, then I would know that it would also converge without the absolute value on it, which would mean that the other endpoint also converges. So if I do take that absolute value, I get this series here. And the reason we might want to do this 2 at the same time is because this thing here is very easy to check. This is a p series, right? P series, p equal to 2. So it converges. And again, since we took the absolute value of the left endpoint, that was really the one that we got when we plugged in the left endpoint. But when we took the absolute value of it and we showed that that converges, that also implies that that must converge. That's the right endpoint, that's the left endpoint. Both of them converge by this absolute value theorem that we had. So therefore, we can say that it converges on both endpoints. And since it does, we can now add both of those to our interval that we got here. So the interval of convergence is what we got before, but including the 2 endpoints. So we'll say minus 4 up to 2, including both. So when you're asked to find the interval of convergence, you have to go a little bit beyond the steps that we had in the previous problem that only required radius. For part B, we're asked to do the same thing, that is to find the interval of convergence. So let's use the ratio test again. So that gives, I'm going to go ahead and write the minus 1 to the n plus 1, even though we know that that's going to disappear because of the absolute values. Now be careful here. This, when I replace n with n plus 1 here, I get 2 times n plus 1, which actually ends up becoming 2n plus 2 there. Be careful about that. And then in the denominator, we get 4 to the n plus 1. Multiplying this by the reciprocal of the nth term, we get this. Okay, now the minus 1, both of these just go away. And the reason for that, again, is because of the absolute value bars. So that might be the first thing you'd want to do, is just get rid of any of the negative terms. So what is left then? So we'll have that. Now here we've got 2n plus 2 minus 2n. That's actually going to leave x minus 3 squared. And then what else do we have? 4 to the n plus 1. That denominator there you can write as 4 times 4 to the n. And notice I didn't put the absolute value bars here because this thing is squared, so that can't be negative anyway. Okay, now these terms are going to cancel. I'll have a 4 in the denominator. In fact, really, that's all that's left. When I take this limit, all the terms that have n are now gone, so this is all that's left. So my limit actually ends up just being that, x minus 3 squared over 4. And again, for convergence, what do we want to have happen? We need this to be less than 1. Okay, and then we can multiply both sides of this by 4. So we'll get x minus 3 squared is less than 4. Now at this point, when I'm solving this, I'm going to have to take the square root of both sides. Now remember that when you actually do take the square root of something, the result is actually the absolute value of the something. So that's where these absolute value bars are actually going to come back in. Taking the square root of both sides actually gives us x minus 3, absolute value less than 2. So that is the radius of convergence, 2. And then what we'll want to do is write this as a compound inequality again. So we get minus 2 less than x minus 3 less than 2. Adding 3 to all parts of this inequality, we'll get 1 less than x less than 5. So that's our interval, but again, we need to check endpoints. So at x equals 1, see what happens. If I plug 1 into this thing, I get 1 minus 3. That's negative 2. So I'm going to have this series. So I have minus 1 to the n. Plugging in 1 here, I get minus 2. So I'll have minus 2 to the 2n power over 4 to the n. Okay, now we need to simplify this a little bit before we can figure out what it's going to do. Notice that this is the same as minus 2 squared to the n. So in other words, I could put parentheses around just that part there, and it'd be minus 2 squared to the power of n. So what we get after we actually do that squaring, we're going to get a minus 1 to the n. It stays there. Squaring that negative just makes it positive. So I'm going to be left with 4 to the n there after squaring that. And then I got 4 to the n here. Notice what happens here. These cancel, and all I'm left with is just this. Negative 1 to the n power. That is definitely divergent. Basically, you're just adding 1 and then negative 1 and then 1 and then negative. So it's bouncing back and forth between negative 1 and 0, or 0 and 1. And so this diverges. Or if you wanted to, you could say that's an alternating series with an being just equal to 1. That limit is definitely not 0, so diverges by the alternating series test. Okay, and then at the other endpoint, I think we'll see probably the same thing happen. So at x equals, what was the other endpoint? At x equals 5, what happens? Plug in 5 there. 5 minus 3 gets me 2 again, and since I'm squaring it, I will get exactly the same sequences or series as I got before. So I have minus 1 to the n. That's 2 to the 2n over 4 to the n. And again, that is exactly the same thing. 2 to the 2n is the same as 4 to the n. So I'll end up, and then they'll cancel. So basically that cancels with that. And so I'm left with this, which is the same thing that I got at the other endpoint. And so that diverges as well. And so what is our interval of convergence? It diverges at both endpoints. So our interval is exactly what we got before. So from 1 to 5, excluding both endpoints.